1. And we are officially live. I'm going to mute us so that we are ready to get started. And of course, aside from burritos, my other super duper favorite in terms of sweets are chocolate chip cookies. I love cookies. So I had to make a cookie word problem, and it's going to be a holiday one today as well. So we've already worked on multiplying fractions and whole numbers, correct? And we found out we had to turn our whole numbers into fractions. And we've worked with estimation of fractions, whole numbers, and mixed numbers. So today should be a piece of cake because we're going to be working on multiplying two fractions. And that is our essential question of the day. How can you multiply two fractions? Which I think we're going to pretty much have down, given that we've pretty much been multiplying two fractions and turning our whole numbers into fractions anyways. So let's take a look at the problem for today. Thank you to Valentina and Fiona for volunteering some Bitmojis. Guys, I'm still looking for more. I'm running out for our word problems, so please keep on emailing me. The more variety I have, the more variety I can put into my word problems. But nevertheless, our problem solved for today is very cookie based, and what better way to kick off our holiday season than with a holiday cookie swap. Valentina and Fiona are baking sugar cookies for a holiday cookie swap, which is basically a party where you exchange different types of cookies. Best party ever. They found a recipe that calls for 3/4 of a cup of sugar. If they only want to make half of this recipe, how many cups of sugar should they use? So we have 3/4, and we're going to split that in half. What operation are we going to need to use to find half of 3/4? So let's stop sharing momentarily. And we're finding half of 3/4. So I've written it at our board. What operation are we going to need to use to find half of that 3/4 cups of sugar, which is a lot of sugar, but hey, sugar cookies. What operation, guys?
Operation.
There's only four operations. Multiplication. Now, so some of you were saying, well, it's multiplication because it's a multiplication chapter, Ms. Velez. And you said it in the beginning that that was going to be our objective for today, to multiply two fractions. But within your actual problem, when it said that you're going to need half of something, what operation are you normally thinking of if splitting something in half?
Division or
division, right? And so why is it multiplication when it comes to fractions? Why, if I want to take those 3/4 cups of sugar and split into halves, well, I have to multiply instead of divide? It's tricky. Does anybody think they know why?
I know.
Jaden?
Because most of means multiplication in math.
Right, so our clue word of tells us we're multiplying, but still, why are we multiplying? Doesn't multiplying make things bigger? If I'm taking 3/4 and I'm splitting it into half, why is it not division?
Because the halves add up.
Because fractions are already division.
Oh, yeah, right.
Half of something means that you are already dividing by 2. So half of 3/4 would be half times 3/4 because the half is already a division of that 3/4. For those still going, huh? Well, also when you multiply, let's say I'm multiplying my denominators, doesn't your denominator get bigger? If it was 2 times 4, and I'm going to rewrite this so that you can see what I'm talking about. So I'm going to use my color coding. You may use whatever 2 colors of your choosing for your numerator and your denominator. So here's our problem. 1/2 times 3/4. Well, when I multiply my numerator, my denominator, aren't I going to get a really big denominator? 2 times 4 equals?
Wait, 2? You don't have to do
No.
that. You don't
No,
have
you
to
have
do
to
that.
simplify. You have to simplify.
Yeah.
Okay, we're going to get to that. We're going to get to that. So my initial question is, why is it multiplication?
It's multiplication
Because
of
if I'm
fractions.
splitting something in half, doesn't that sound like division?
Yeah,
Because
but
all
if you
fractions are
think
division
about it,
problems.
but if you think about it, it's already division, right? So
When you have a
if you
fraction
do-
of something, it is division. But
yes,
why
but
did I choose to multiply then? Here's your
because you chose to multiply, because if you do division again, then how are you going to do that if they're already division?
Ready?
And if you do multiplication,
Hold on.
okay.
So you're repeating what I said, but I want to show you something. If I have quarters, right? I had 3 quarters. So here's my quarters. Here's my quarters. Does everybody see quarters?
Yes.
So
I
3
think so.
quarters. Ready? 1, 2, 3. If I were to split those quarters into halves, how many pieces would I have all together? I split the fourths into halves.
6.
Okay. But how many all together?
8.
8.
8. So didn't I have to multiply 2 times 4 to get 8?
Oh, I get it now.
So when you are splitting something, when you're dividing
yep.
something, you're actually going to use multiplication with fractions because your denominator is going to get bigger, but your pieces are going to get
Smaller.
smaller. You are dividing, right?
Oh,
You
I
are
get it, I get
dividing with multiplication, but your denominator gets bigger, which just means you have more pieces, but they're each smaller. So I'm going to take that 3 quarters and I'm going to split it in half. Yes?
Wait, did that mean that you're supposed to multiply the first denominator with the second denominator and the first numerator with the first
Right,
numerator?
right. So now,
Ah!
now that I've split it into eighths, how many are colored in?
6.
6. And what is half of that?
3. Half of 6
Is 3, yes?
Oh,
So
yeah.
now that we know that we're going to have half of 3 quarters, we're going to have now we can actually solve. 1 times 3 equals
3.
Multiply your numerator by your numerator. And now multiply your denominator by your denominator. 2 times 4 equals
8.
8.
But Miss Celeste,
So
can you just
here it
turn
is.
2 into 4?
1, 2, 3. Half of that 3 quarters is going to be 3 out of 8. Does everybody see that?
Makes sense.
Yeah, Miss Celeste.
Oh,
See why you would use multiplication instead of division?
Yes,
Yeah,
Miss
that's what I
Celeste.
get.
But
You're going to double your denominator, which means that your pieces, it looks like it's more, but they're actually smaller. All right, that's why we use multiplication. So in that case, we're thinking about the sugar again. How many cups of sugar are we going to need?
they're going to need 3/8.
3/8. We're no longer going to,
sugar.
we split that 3 quarters of sugar into half, and half of 3/8 is, I'm sorry, half of 3 quarters is 3/8. All right, so 3/8 of sugar. Woot, woot. Now,
Miss,
yes.
can you just turn 2 into 4 because like 2 goes into 4? But you multiplied.
so-
This is different.
So, well, no. I see what you're saying. You're thinking you can simplify here. Remember, the rules for simplification is it has to be a numerator and a denominator. It cannot be 2 denominators or 2 numerators. Remember when we were simplifying our fractions, whatever you do to your denominator, You do to your
Due to numerator.
we never said whatever you do to your denominator, you do to your other denominator, right? These are division problems. So whatever you're changing your dividend, you're changing in your divisor. You're not changing two of the same value, right? So 2 and 4 look like they can simplify, but they can't. It has to be a numerator and a denominator. So 1 and 2 or 1 and 4, 3 and 4 or 3 and 2. And as you can see, nothing can be simplified. So we would have to just multiply across numerator times numerator, denominator times denominator to get a final answer of 3/8. And to solve the problem, it's not just 3/8, but it's 3/8
Sugar.
cups of sugar. Don't forget
Cup
your
of
unit
sugar.
when you're dealing with a real problem, right? Solve the problem, not the equation.
That makes sense.
All right. Where's my, okay. Let's continue. I want everyone to follow along with me. Let's try some practice problems on page 283. Are you all with me on 283? All right. 283. Let's try another one. We'll try number 1, 3/4. And you know what? I keep forgetting that I want a color code for you guys. So 3/4. I'm going to write my numerators in orange and my denominators in green today. And as long as you have 2 separate colors for numerator and denominator, I don't care which colors you use. And we're multiplying.
Okay.
If we're multiplying, hopefully you know our denominator is probably going to get bigger. Yes?
Yeah.
Because when you multiply, you're actually splitting into smaller pieces. More pieces, but smaller. All right, let's check with our trick if we can simplify inside of the problem. Are there any numerators and denominators that share a common factor? Meaning a number that can be divided into both numerator and denominator perfectly without a remainder.
No.
One?
No.
Ashley, you see one?
Yeah.
Where?
I just messed up.
Wait, don't 7 and 4, they go into like
They're going to 28.
28 or something?
But that's multiple.
But that's
We're not
not.
working with
Yeah,
multiples.
that's
We're working
what
with
multiples
factors.
are.
There's
Not
like
listing what
Do you guys
the
remember the
factor
difference?
is.
Multiples are your times tables. So 4, 8, 12, 16, 20.
numbers that
Right.
lead to the problem answer.
Factors are the numbers you multiply to get that number. So 1 times 4 or 2 times 2. So the factors of 4 would be 1, 2, and 4. They're the only possible numbers you can multiply. So knowing the factors of both of these numbers, do they have a factor in common?
One.
No. Nope, they do
They
not.
don't. No, there's no
Yes,
number that
yes.
goes into both 4 and 7 perfectly.
One. Oh, 4 and
Well,
7.
1 doesn't count because the number stays the same, right?
Yeah, but it's still a number.
No, simplifying means dividing by anything besides 1. If you're dividing by 1, you're going to get the same number. That's not simplifying, that's staying the same. So none of these numbers can be simplified because they do not have a common factor. Do you agree?
Yes. Yes.
All right, so guess what? Since there's no common factor, we're going to just multiply our numerator times our numerator and our denominator times our denominator. So let's start with the 3 times 7 is
21.
21. And the 4 times 8 is
32. 32.
32. Fifth graders, is my answer in simplest form?
Yes.
How do you know?
Oh,
Because nothing that that goes into 21 and 32 goes into both. So and 21 is
less than your denominator. Your numerator is less than your denominator. So I think you don't.
Well,
It's in simplest form.
with all proper fractions,
Yeah.
your numerator is less than your denominator. But here's your biggest clue. If your answer could have been simplified, we would have done it already in this step,
Mhm.
right? If
Yeah.
it could be simplified, we would have already seen where it could be simplified inside the problem. Since we couldn't simplify anything in here, that means our answer is automatically in
Simplified.
simplest form. It's in the simplest form. Let's try another one. Shall we?
Yeah.
Yeah!
Love math.
No.
All right, ready? And I get my color coding again. Let's try number 7. I'm going to write my numerators out and my denominators out. And let's get multiplying.
Nope, there's no numbers that could either go into the denominator and the
Are
numerator.
you sure?
Wait.
Everybody, well, don't shout it out. Don't shout it out. Who sees a numerator or a denominator that has a common factor? Look closely before you say no.
I just saw it.
Look closely because I see.
I do.
I see 2.
I'm looking
I
for
see
you.
two too. I
Me
just messed
too.
up.
All right.
Two
What-
obvious
What
ones.
numbers can be simplified? Kayla.
Well, the 5 and the 5.
Yes, the 5 and the 5. They
Just
are
be
the
turned into
same
one?
exact number. And what do you get when you have 5 over 5?
One.
Oh.
1. So guess what? These, I call this canceling out. If you get 2 of the same number, that's a woot woot, almost a freebie because they're both going to turn into
One
One.
whole.
1 over 1, which, you know what? If they're both going to be 1, if I wanted to, I don't even have to write it because anything times 1 is going to be itself. So I could just kind of cross them out and not be bothered with them and only worry about the 3 and the 9. By the way, speaking of the 3 and the 9, can that be simplified?
Yeah.
Yes.
What can they be divided by?
It can be
me?
divided by 3.
Perfectly,
You lagged out for a
right?
second.
Divide by 3.
Oh.
Divide by 3. What does this turn into?
1.
1.
1.
9 divided by 3 turns into
9 divided by 3.
3.
3. So guess what? This is like the best case scenario because all of our fractions simplified. Now we just have to multiply across. 1 times 1 equals
1.
1. 1 times 3 equals.
3.
Is my
Also-
answer in simplest form?
Yes.
How do I know?
Because a 3
you can,
is an odd
you,
number.
1, you did all the simplifying in the first step, and 2, your numerator is less than your denominator, and you can't simplify anymore.
A lot of the times, all proper fractions, my numerator is going to be less than my denominator. But there are certainly 2 clues. One being, I did all of the work already. I simplified my fractions inside of the equation before I got my answer. So I saw here there was nothing else that could be simplified. There were no other common factors besides 1. Second clue, I have a numerator that is 1, which means it can't be simplified any further because 1 is in simplest form.
It would equal 1/3.
Smallest number you can get in any fraction. So 1/3 is in fact in simplest form.
I think I understand.
And we got that beautiful freebie right here where they canceled out. I love freebies. All right, let's try another
Yes.
one. Not bad, right? Not
I
bad.
have a
not
fear
bad.
of these.
Bees? What are we talking about bees for?
In this chicken, let's talk
All right.
about toad.
Let's try number 16. 7/8 times 2/5. 7/8 times 2/5. All right.
No. Okay.
Before we could just do 7 times 4 and 8 times 5 and get 14 over 40, but then I'm going to have to simplify. Does anybody see anywhere we can simplify
Yes.
inside the
Oh,
problem?
yeah, right. Yes,
Any
yes,
numerator
yes,
and any
yes.
denominator?
Yes. Yes.
Where?
Yes.
Which
Yeah.
two? I'm looking for a hand in the crowd. Kai, which two?
Okay. 2 and 8, and it can be divided by 2.
2 and 8 divide by 2.
So it's
Divide
14.
by 2. We get what?
You get for 2
1
you get 1,
and
and for 8 you get 4.
4. Are there any other numbers that can be simplified? Good job, Kai. Are there any other numbers that can be simplified?
No.
No. So what's our next step?
The two
Multiply
turns
your
into one.
numerator by your numerator, your denominator by your denominator. So let's do that.
How did
7 times 1 equals
7,
7.
Wait.
4 times 5 equals
20.
20. Is my answer in simplest form?
Yes.
How do you know?
I know.
Because we
How
already
do you
did
know?
the
Yes.
simplifying
We
part.
already simplified as much as we could within the problem. So we did that step. Now, if we didn't simplify, we would have gotten 7 times 2 is 14. 8 times 5 is 40. We would have gotten 14 over 40, which is definitely not in simplest form. And we would have had to divide to simplify. But
Okay, I get
we
it.
already did the division inside, so we're in simplest form. How are we feeling so far? Confident?
Wait.
Feeling
How did
Yes.
How did
Yeah.
So good I could do it mentally. So good I could
Yeah,
do
a
it
lot of them you
mentally.
Let's see.
How did
Let's
the 2 turn into a 1? I'm confused by that.
Okay, so
the 2.
Yeah.
For which one? I'm sorry. I lost. I
For
should have
the
kept it
for
up.
the last one that we did, the fourth problem that we did. 7
Can you
8
remind
times 2
7
fifths.
eighths? 7 eighths times 2 fifths.
Because
It
I'm
turned into a
confused.
1 because we divided both these, the numerator and denominator, by 2. Divide by 2. 2 divided by 2 equals 1. 8 divided by 2.
So you just okay.
Four. Right? And then so it's just like, remember when we had our Pokeball, 2, because we can switch these order anytime we want, right? Because we're going to get the same answer. I put the 2 here, I put the 7 here, I'm still going to have 2 times 7. So watch. Pokeball would be divide by 2, and we would get 1/4. We get 1/4. See it?
Yeah.
Oh, so basically you just have to divide the 8 by 2 and then divide the 2 by 2. So it's the same thing, but
Right.
you get
Just
different
like
numbers.
whenever we simplify, you divide the numerator and the denominator by the same number.
Okay.
That's how you simplify. Okay?
Okay.
All right. Now I wanted to try one that had 3 fractions. So let's see if I can draw this out for you. Well, let's look at number 14. 1/2 times 3/8 times 3/4.
Countries, right? Countries. 1, 3, 3.
All right. So for this particular one, we have 3 fractions, but since they're all the same operation, I can still use my same rule. I can simplify any numerator by any denominator, because remember, if I switch the order of these fractions, the numerators and the denominators, I'm still going to get the same answer. That's our commutative property. Remember that? You can switch the order, but still get the same answer. So any numerator and any denominator can be simplified. Do you see any numerators or denominators that can be simplified?
8 and 4.
Yes. 8, 4, and 2. The whole bottom row.
Oh, really?
They can all be divided by 2.
Those are all numerators and denominators?
I got the
Wait.
I wanted to see if I was going to trick you, and I did.
They're fine. All of them are fine.
Nothing can be
Yeah.
simplified.
What are you talking about,
Nothing.
bro?
Why?
And that makes it much easier.
Because
These are
you-
all denominators, fifth grade.
yeah, and those are all even too, and all those are
Right.
odd.
I showed this one to you in particular because I know that once you see it, it's tempting. Like, oh, yes, 2, 8, 4. And our mind is so trained to finding that shortcut, finding the way to simplify, that we forget, oh my gosh, they're all denominators. They look like they can be simplified, but they can't, because you must only simplify a numerator and a denominator. So for this particular problem, nothing can be simplified. We're going to have to just multiply across. 1 times 3 equals 3. Times 3 equals
9.
9. One person. 2 times 8 equals
2 times 8 equals 16.
16.
16 times 4. Anybody have that at the
64.
24.
64.
And is that in simplest form? Is that in simplest form?
Yes.
Yes, because we couldn't we know it's in simplest form because we couldn't simplify it in
Yeah.
the problem. If we couldn't simplify it here, it's not going to get simplified out here. So that was a trick one. You guys fell for it. Numerators cannot be simplified with numerators. Denominators cannot be simplified with denominators. It must be a numerator and a denominator. All right. And let's see if you remember how to multiply with a whole number. So let's try this one. Let's try number 10. We're hopping around a little bit. 2/3 times 5/8 times 4.
2/8 times 5/3 times 4.
Fifths.
2/3 times 5/8 times.
What's the first thing we have to do before we can even try the trick?
Change
The
that
4 and 2, 4 ones.
4 over 1.
Right, you can't have a whole number. They must all be fractions, so we must change it to an improper fraction, which is 4 over 1. Oh,
Because fractions can only be times or divided by fractions.
right, exactly. All fractions
This
are
all has I
division
found
process.
one.
All
I
right.
found actually 2 sort of. It's sort of like 2, but it's sort of like 1.
Right. There are
They
2
both involve
possible
the
approaches
first-
here.
They both involve the one.
All right. Let's hear from someone I haven't heard from. Patrick.
Hello?
I know all I see is your ceiling. So
Yeah.
I don't know if you're here or
I'm here.
been invaded by aliens. I don't know.
Okay.
You're here.
You can do
All right.
invaded by aliens.
I don't know. Well, we never know.
Call the FBI.
All right.
Call everyone.
All right. Patrick, and only Patrick.
I can
You
tell
see any numerators and denominators that can be simplified?
the 2 and the 8.
The 2 and the 8. What can they be simplified by?
They can be simplified by 2. But you
Okay,
can also do the
simplified.
4 and the 8.
Well, you could, but once you've already picked one, you got to
Yeah.
stick with it, right?
I guess I'll just do 2 and the
So 2 divided by 2 is
4.
1, and 8 divided by 2 is
4.
4.
Now. Good job, Patrick. Even though you said, oh, when we got rid of the one I was going to simplify, can you simplify again?
Yes.
Yeah.
Who sees another set of numbers that can be simplified again? What about Chris? Chris, are you with us? Chris?
Sorry, I'm
Oh,
sorry.
okay. I
I'm
thought
here.
you were abducted by aliens as well. All right. Are there any other numerators and denominators that can be simplified, Chris?
Hmm.
And I'm going to double cross these out so we know that these are already taken.
I think if there was one.
I can
No, I don't see any.
You don't?
No.
I spy with my little eye.
Can I say
Another set of numerators and
Yeah, I
denominators
do.
that can
I
be
do.
simplified.
I do.
Hmm.
I've been seeing.
I do.
Anaya, do you see any?
I see more. Yeah, see two.
I spy with my little eye another set of numerators and denominators that can be simplified.
There's 2.
Hold on.
Yeah.
So many people, Anaya, you have a very popular name. So many people have this same name. Wow. I thought when I looked at my student roster, there was one Anaya on it. I don't know. I've had like 5 answer me today though. All right, Anaya, do you see any other numerators and denominators that can be simplified?
You could do 1 and 5 and 1 and 4.
I'd love to, but is it really simplifying if you're only dividing by 1? We're not getting any smaller. It's going to be the same, right? Who thinks they have it? A lot of people getting stumped on this one. A lot of people are getting stumped.
Choose.
Lila, save us.
The 4 and the 4.
Yes, the 4 and the 4. Yes.
Finally.
4 and 4. And that's another freebie.
One.
They cancel each other out. 2
It's
is the
another
same
freebie.
number. So guess what? I could just cross them out because they're the same number. They're both going to turn into a
1.
1 because I
One,
divide
one,
by
one,
4.
one.
Divide by 4, and I'm going to get 1 and 1. If I wanted to, since I know they cancel out, I don't even have to write that because anything times 1 is going to be itself.
So it would be 5 and 3.
So now, is there any final step? Are there any other numbers? I'm going to just cross these out completely because they are 1s. Are there any other numbers that can be simplified, numerators and denominators?
No.
No. So all we have to do is multiply our numerator by our
Multiply.
numerator, denominator by denominator. And we only have 2 left in each. 1 times 5 equals
5 and 3 times 1 equals.
Oh, but simple.
But wait a minute.
said that out loud.
Yes,
You
it's
can't do
simple.
that
we
Because-
can't.
because the
It's
5
improper.
is greater than the 3.
Oh
It's improper.
no. What are we going to do about that? We have a numerator.
improper.
Our numerator is greater than our
It's
denominator.
1, 2, 3.
One whole. That's
One
improper.
whole.
Proper.
Bravo.
Who would like to tell me what I need to do?
Proper.
Yes.
Change the 5
Change.
to 1 whole.
Division.
Yes.
Division.
All right. We have too many
Division.
people talking at the same time. Let's chill for a minute. All fractions are division problems. So 5 over 3 is the same as 5
5 divided by
divided by 3. How many times does 3 go into 5?
Uno
One.
time.
1 time with a remainder
One remainder
of
2. 2 with
2
the R.
out of.
3.
3.
So instead of writing 5/3, we would write it as 1 2/3. Dum dum dum! We did it. How do we feel?
Hi, how are
Can you
you?
do this on
Good.
your own?
Yep.
Yeah, it's pretty
I can do
simple.
this. I can
So
do this.
I want to know how in the chat. The chat is private currently. So in the chat, let me know how you're feeling. And if you want me to do another sample problem, I am so willing to do another sample problem. And then we'll take a quick peek at the homework for today. And I will post this video in case you need an extra review.
Yay.
Yay.